Yes, Chairman. Yesterday.
Is there any message in the group? Can you check? Because attendance is very low.
Nothing, Chairman.
Nothing is there? Okay. In that case, I will only wait 2 more minutes and then I will proceed. Do you remember till which slide we discussed in the previous class? I think hypothesis testing we did. I was somewhere, yeah, this slide was done and I think I was somewhere here and there. Correct?
After next slide, Chairman.
Next. Here, we were.
Yeah.
Here? Yes.
I think so.
Yes, degree of freedom. Correct. Yes, thank you. I remember it. So I hope you all got time to go through and is there any questions so far? Okay.
No, Chinmay.
Yeah.
Perfect. Let's talk about degree of freedom. Okay. So I will tell you one thing. Yeah, I think now I am properly audible. Correct? Let's talk about degree of freedom. Okay. Degree of freedom. And if you remember, we used this term when I was explaining ANOVA. Do you remember it? So we calculated in
Yeah, it would be.
Yeah, tell me.
Yeah, it would be like number of groups minus one group.
Yeah. So degree of freedom is something which is calculated like n minus 1. Again, it depends that n is number of group, n is number of element. So in different context, degree of freedom is calculated differently. If you remember in chi-square, we calculated degree of freedom like row minus 1 multiply column minus 1. That's how the degree of freedom was calculated. Got it? In chi-square, when I was explaining the chi-square analysis, we calculated degree of freedom in this way: row minus 1 multiply column minus 1. I hope you all remember it. Am I audible? Can you hear me?
Yes, sir.
Yes, Chennai.
So we calculated like this: r minus 1 row minus 1 multiply column minus 1, and we got a degree of freedom. Getting it? So yes, we essentially calculate by help of minus 1. That's how it is coming. So there are different contexts here. At the very basic level, the way we are going to talk, we are considering this first method, which I highlighted, as degree of freedom. And I will tell you the context for this one, that what is degree of freedom and why it is so important. Okay? So I will give you the example. In statistics, whatever we talk in terms of sample. And listen it very carefully. We consider on the basis of sample. Let's say that you have 5 shirts which you use for office wear, office purpose. You have 5 shirts, and you get the weekly cleaning of the shirts, so that on Saturday Sunday you get it prepared for the next week. Okay. So on Monday, how many options you will have to select the shirt? That which shirt you are going to wear? How many options you have on Monday?
5.
5C1.
5.
So on Monday we have 5 options. Got it? On Tuesday,
4.
4. On Wednesday,
3.
on Thursday,
2.
Monday, Tuesday, Wednesday, Thursday. On Friday,
No option.
no option. Got it? Because you are left with only one shirt. Got it? That means when we talk about selection, sampling is all about selection, wherein we, from the big population, we select something. So if you have 5 elements, you have only 4 ways to select it. These ways are highlighted here. You do not have the 5 ways because at the last you have no option. So degree of freedom is, this is what the degree of freedom, which talks about, this is the real context that will give you the clear picture. Degree of freedom says that if you have some numbers given and someone is saying that how many options you have. So number given -1 is what we call option. The way we saw here that we have only the 4 options. We can only select it in 4 ways. And these 4 ways are highlighted in yellow color. That's what the degree of freedom is. Is that clear? You can think. So look here, it's saying that mandatory number of courses you need to take. Fine. Or saying that number of courses on offer. So you have only degree of freedom 9. If there are 10 courses which are mandatory, so it is going to be 9 degree of freedom. The way in the 5 charts we just saw that we have only 4 degree of freedom. The same example is saying that you have to take 10 different courses. to graduate and only 10 different courses are offered, then you have 9 degree of freedom. You can only choose till 9. 10th is by default. If you are going to reject everything, if you reject 9 courses, then it's only the 10th course which is left for you. At that point, post 9, you do not have option. Is that clear? I hope this context is clear to everyone. Now I'm moving to next slide. Now, then talking about the p-value. If you remember, we had discussion about the p-value. And depending on where are you looking at the one tail or are you looking at the two tail, we decide that which one is going our rejection region. Like in this case, if the place where my cursor is moving, if any value is coming right side of this, you are going to reject it. Now, in that context, be careful. The measure of the strength of evidence that the sample data provide against the null hypothesis, that means the data that is given to you, you try to measure how close that data is with respect to the hypothesis. And we write null hypothesis. That's what the evidence we figure it out. Then saying that the small p-value indicates strong evidence against null hypothesis. And the large p-value indicates weak evidence against null hypothesis. Got it? This is what the thumb rule is. So what all is given in bullet number 3 and 4, that is the thumb rule to decide that should we reject or we fail to reject. I hope this is not new for you. We discussed the same context many times in past. Is that clear? Now, then talking about the two-tail test. That in two-tail test, we have your rejection is coming both the sides. And you remember in two-tail test, I explained that your hypothesis is written in terms of equal to. Either it is equal to or it is not equal to. We never use less than greater than symbol. Less than or greater than symbol is used in case of one tail, be it lower tail or be it upper tail. This is what the same story it is conveying. I hope it is clear.
Yeah, clear, sir.
Now, then talking about the left tail test. So in left tail test, your rejection is going in the left side. And look here, your alternative hypothesis is saying less than. Look your alternative hypothesis sign, symbol, it is saying less than. That means your rejection region is going to fall in the left side. Now, when your rejection region in right side, look here. Here the sign for null hypothesis is, for alternative hypothesis is greater than. Mu is greater than mu naught. So in that case, your rejection region is going right side. I hope it is clear to everyone. That's what even in the previous class I explained in Excel, that look how things are looking. Now, then we are moving to something called parametric test. Now, as name is suggesting, there are certain meaning for parametric. First of all, what is parametric? That I need to explain. In statistics, there are two types of distribution. Fine. Types of distribution. Type of distribution. So the first type talks about distribution which follows predefined equation or shape. And second, there is no predefined equation or shape. Yeah. These are the two types of distribution. Listen it very carefully. I'm saying a distribution which follows predefined equation or shape, like your T, Z, F, chi. Getting it? These are a kind of a distribution wherein these are predefined. Like all previous binomial, Poisson, these all equations are predefined. That if your data is looking like this is the behavior, then this is similar to this distribution. I hope you are getting it.
Sir, what is this predefined?
For T we have equation, for Z we have equation, for F we have equation. So this everything is coming by certain equation which we know, and there is table. For T table we have T table, Z table, F table, all tables are there.
Okay.
Getting it? So this is called predefined. That means those distributions wherein we have table available. Getting
This
it?
is like types of distribution we are talking about, right?
Right. And
In
second
that,
is,
like we are,
tell me.
Yeah, in that we are given that the distribution which follows the predefined equation means. So
That's what-
types of distribution in that the predefined
Now you tell me,
equations
do
means.
you remember the equation of T? What is the, or Z? How the Z value is written? Do you remember it?
I mean to say, like right now I didn't remember the equation. I know
That's
that
what I'm
the
saying.
equation is there. It's a
Yeah.
discuss.
So this is the equation. That's what I wrote. Whatever I have written here, these everything has equation. Got it?
Okay. Equation or shape.
Right.
Shape also there.
Yeah.
Okay. So one is equation is there, other one is no equations are there. Yeah, right.
Now, is there any further question? India, you were saying
No,
something?
sir. No. Like one is the equations is there, other one is no equations are there.
Correct.
That is what I said. Yeah.
Yes. So if there is no predefined equation or shape, then that is called, there is one distribution, and those distributions wherein something predefined, like I think I will tell you one thing. In statistics, first of all, the statistics is like ocean. It's a big word wherein there are many things that we do. So just for your reference, I will showcase some table that will give you idea. So if you see here, are you getting how many pages it is saying? 881. Is that clear? It is 881. Got it? That means I have one book which talks about statistical table, and those are the number of pages, close to 800 pages. So you think that how many statistical distributions are there? And this is completely filled of numbers. Can you see?
That is what, sir. Actually, if you go to any Google or somewhere,
Right.
we will be confused. There will be a lot of information is there.
Yeah.
In
So
that, we will be confused that what to. Yeah.
I suggested initially that do not go to Google, do not go anywhere. You focus what all I'm explaining. So that is the reason that I only wrote this 4 table. I didn't write something which is coming from some other place. There are many tables, and for our understanding, these are the 4 distributions that we are going to talk in future. Primarily, these 4 distributions are primarily used distribution. Got it? Now,
Okay, sir.
then comes the distribution wherein there is no predefined equation or shape, and second is a distribution wherein the predefined equations or shape. So the first type of distribution is known as parametric, and second is called non-parametric. Got it? So parametric is the first type of distribution. Name for that is parametric, and second is non-parametric. This is what the name is given. So in statistics, that's what your PPT is saying, that we are going to talk about something called parametric test. So parametric, that means those tests, or those, essentially the moment I'm saying test, this test is based on distribution. So those distributions wherein we have predefined equations, those are called a parametric test. And if you see the example, look here. Saying that when you get the data, you check for normality. Okay, and be careful. As I mentioned, that statistics is something wherein your 95% cases falls under the normal distribution, that your data is following normality, normally distributed. But yes, there are certain instances wherein data do not follow normal distribution. Getting it? So here this slide is saying that first you get the data, you need to check for normality. There will be two things. Either your data will be normal or your data will be not normal. When your data is normal, then we are going to use these all: Z-test, T-test, ANOVA, F-test. These all tests happen. That's what I explained. This all comes under your what all we discussed. Clear?
Sir, what is the meaning of pair test?
Okay, so pair test. Pair test is understand what happened. It is saying that the one tail, two tail, T test we all got, Z test we got. Okay, let's say that you are trying to understand the impact of a medicine. Okay, that is medicine helpful or medicine is not helpful. Let's say that medicine is about checking the blood pressure. So what are you doing? What are you doing? I will tell you. It is Z or T test only. Pair test is something which has different context, not the different calculation. So I would say that you have two set of the sample. In one set, you are giving the medicine, and in second set of the people, not original medicine. That's how the test happened. Do you know there is a in medical world there is a term that is called placebo. Placebo. This is a medical term. What is meaning of placebo? You are giving medicine to someone. Someone is considering that he or she is taking medicine, but technically that is not the medicine. That's a sweet pill. That is looking like medicine, but that is not the medicine. Getting it? So what happened when we test the impact of something? Let's say that you have 50 blood pressure patients. Okay, out of those 50, or let's say that you have. Let me count this. 1, 2, 3, 4. I will tell you. Let's say you have 10 blood pressure patients to whom you give medicine, and you have another 10 blood pressure patients to whom you didn't give the medicine. You simply give the sweet pill. So these all 20 patients are considering as if they are taking the medicine. Getting it? And then you are going to check the impact that medicine is working or not working. So there is something called psychological impact. Sometimes we feel that we took some medicine, that means we are going to be good. Getting it? So either medicine is working or not working, but we feel good. Getting that?
Yes, yes.
That's
Like
what-
someone takes
Yeah.
an immunity boosting medicine,
Right.
then that is not considered as the actual medicine, right?
Right.
So we can call it as placebo.
Yes. So placebo is something which is kind of something which is not actually the medicine. It is very similar looking medicine, but that is only for the test or experiment. Okay. And now let's say that you have two tables. One is saying that BP before medicine, and then you are saying BP after medicine. After medicine. And this is for the first group. Then for the second group also you are getting this information. Getting it? And then you are comparing that is your medicine is helping to control the BP or it is not helping. That is called the paired test, wherein we pair it. Are you getting here? For the first person I'm pairing before medicine and after medicine. For the second person also I'm saying before medicine, after medicine. This is t-test or z-test only. So in terms of statistical calculation, it is only t-test and z-test, but we call it paired. Reason being, the objective is to measure the effect of some activity.
Okay.
Got it?
Got it.
That is what it is saying, the paired test. Now, then in non-parametric, I think we all know about Z, t-test, ANOVA, f-test, that discussion we had. Something new is given here. First is called the Mann-Whitney test, and second is called the Wilcoxon sign test. First of all, this is used for not normal distribution, and in data science, we do not consider any kind of not normal distribution. If your data is not normally distributed, then we do something to make it normally distributed. There are certain processes which makes your data normally distributed. We'll talk about those processes. Considering that only, we are not going to do a lot of detailing about not normal distribution, reason being that is out of our discussion. And the second is we have ways to tackle this issue, that for the non-normality. So I will explain the moment we go to this linear regression or logistic regression. There we'll check that how to perform, how to convert something into if something is not normal, how to convert that into normal. We'll do that. Now, then it is saying that for,
Yeah,
tell me.
in the previous slide, I haven't done.
Tell me.
Yeah, in this we have ANOVA is under the name, right?
Yes.
So F-test also we use ANOVA. So how is it
No,
different?
F-test. So
F-test is
technically, the way F-test is calculated, got it? That talks about the variance. You use under ANOVA. So under ANOVA process, the F-test was one of the way to measure it. But if you look, technically it is saying that your all Z-test, T-test, ANOVA, that walk over mean. But when you are talking about the variance, this is the F-test. So the question comes,
so
what is the consideration? What is the consideration? If you remember F scenario, in F, we calculated variance. We didn't only calculate mean. By help of mean, we calculated
Yeah.
variance and then we proceeded.
Yeah. So what is HOV?
It is called Hove test, homogeneity of variance. HOV means homogeneity of variance.
And one more thing, like in Z-test also we will be having one-tailed and two-tailed, right?
In it will be, but understand when we talk about a tail, it is only the T test. It's not the G test.
Okay. But there also, if it is not equal to condition is coming, then it will come.
It will be, but normally in the case of population, we do not think in that way. This all happens in the case of sample only.
Okay.
That's why we call it.
Okay, thanks.
Now, then, as I mentioned that if you look at the first flow, it is saying that once we get the data, we need to check for normality. Your data is normally distributed or your data is not normally distributed. So here we have certain ways to check for normality. So saying that normality test establish if the data approximately follow normal distribution. So there are many tests which is suggested for the common test for normal distribution. For us, we are going to use only the first part, the probability plot graphic methods, because that is the most powerful. The remaining three tests are very contextual. Those are applicable in some cases, not applicable in some cases, but not the first one, the normal probability plot, that is applicable almost in every case. So we are going to focus more on the normal probability plot, not on Shapiro, Wills, Anderson, or case test. That will come later when we go to the Python, some deep learning part. There we'll see those are very, very specific. In very selective case, some of the tests are used, but probability plot is used almost everywhere. Now, then we are going to talk about the first method, that is the normal probability plot, and I will explain you how does it look like. Let's say that I have something called calculated and something called table. You remember in some of the previous exercise, we calculate some value and then we compare with the table like chi-square. In chi-square, we calculate chi-square value and then we compare with the chi-square table. That's what we did.
Yes, sir.
So listen very carefully, because these are all concepts, and you watch as many as possible YouTube, but getting these concepts are very rare because you may miss those conversations. So let's say I'm talking about the multiple instances, multiple scenarios. You are given data like, let's say that you are given multiple data and talking about the data 1, 2, 3, 4, 5, 6. I'm talking about the data points. These are the 6 data points I have. and I want to, let's say that calculated value is 2 and table value is also 2. Be careful. What all you calculated is 2. When you're looking at the table, that is also 2. Your calculation is, let me start from 1. You calculated 1, table value is 1. You calculated 2, table value is also 2. That means what all you calculated, the same is given for table as well. Now, then let me plot it. I'm saying insert and then plot. Okay. Did you see what happened here? It is saying that look here, 1 1. This point is saying that what you calculated, okay, that is the actual. So if you see at this, the slope of this line, you will be getting that this is going at 45 degree. Because what your x-axis is, y-axis is also the same. Getting it? If I do like 0 0, that will, and then let me do 1 1 to have the better graph. Just a moment. I wanted to pass it from origin, that's why I did it. It is somehow it will show. Oh wait, 0 1. Yeah, I wanted to get it passed to 1 2 3 4. Yeah, are you getting how it is looking like? It seems that it is passing at the 45 degree of angle. Clear? Now, if you plot your calculated value and the table value, and if that plot is following this 45 degree angle, that is indicator of normal distribution. That's what your next slide is saying. So look here. It is saying that sample and theoretical. Sample means the calculated, what all you calculating from your data, and theoretical means the table value. Getting it? When you plot the points between sample and theoretical, that is calculated in table, and if you realize that your points are going to follow like diagonal line, that is indicator that your data is normally distributed. Clear?
Chinmay,
Tell me.
so the data that we have here, we take some of the some parameters from data and then plot a graph, or we plot the graph, I mean, plot the data as is.
No, so it so happened that for, as I mentioned, that whenever we get any data, we need to compare with some predefined equation or predefined shape. Got it? Let's say that you are getting some data and you are planning to do some t distribution or z distribution, or even chi-square. So what we did for that data, we calculated one value like chi-square we calculated, and then we compare with the table value. Got it?
Yeah.
That's what the given here. So saying that the sample, that means the data you got, that is your calculated value from the sample, and what is the theoretical value for that, that is coming from the table. Both we need to compare.
Got it. Thanks.
And this is called QQ plot, that is quartile plot. So name of this plot is QQ, that is quartile. And we know that quartile is 1/4. Getting it? So normally the name for that is, reason being it is plotted. Usually we split data into multiple parts and then we plot it. So the name for this graph is quartile plot. It's saying that it is easy to interpret and outlier detection is easy. So the best part with QQ-plot is you can easily do the interpretation and you can find the meaning. It is quite easy. Clear? It's saying that if data is normal, the points would fall approximately on straight line. The way this straight line is given, your data will fall approximately on the straight line. Going forward, we'll run some query and there we'll do this plotting. Here, we need to understand, we need to get the framework that this is what the requirement is.
Sir, I had one doubt.
Yeah, tell me.
Suppose if a problem statement is given, we check whether whether the number of observations is less than 30 or more than 30. Based on that, we do the Z test and P test.
Right.
Now to detect whether the given problem data is the data statement is follows normal or not. We need to draw this QQ plot before carrying the test or after carrying the test.
Yes. So I would say that one way is to draw this plot to check that your data is normally distributed or your data is not normally distributed. Fine. Other is without drawing this plot, we have other statistical methods which help us to figure out that data is normally distributed or it is not normally distributed. I'm talking with the plot, reason being it is illustrative. Getting? Yeah, tell me the question.
Suppose, like you told that we need to check all the data points and we need to come to the conclusion that the data is normally distributed. Like if there are, like in the earlier example while explaining the t-test, you gave the example of the mean salary of some accountant is 170. Okay, in that particular case, do we need to plot all those points and compare the data, or how is it?
That's how it happened. I would suggest that before we go for QQ plot, first we need to do histogram. Getting it? The moment you do the histogram, you will automatically come to know if it is following bell-shape, that means your data is good.
Okay, that is normal distribution.
That is normal distribution.
So you are giving an example problem as well, right?
Yeah.
You are giving example problem as well, right, for this understanding purpose.
It will not come here. That it will come in the regression part, wherein we get some data and we perform certain outlier detection and normal distribution.
In that regression, everything will be included. Whatever we are covering the stages, parametric test, t-test, everything will be covering.
Many things will come. I would say what all theory discussion we are doing here, many things is going to come there as well.
Linear regression.
Yeah, right. Even if post completion of this chapter, we'll do some exercise. I will run some query for EDA and we'll perform many tasks. Getting it?
Okay.
We have another test, as I mentioned, that the first is in our list is this is normal probability plot. And after that, I mentioned that we have Shapiro and Anderson and KS, that is Kolmogorov-Smirnov. So this the three tests starting from Shapiro, Anderson, and Kolmogorov, these are not too useful, though it is given. I will just give you a glance and then I will move. So for Shapiro-Wills test, it is first of all again help us to check the normality of the data. So null hypothesis is that a sample x1, x2, x3, xn comes from the normal distributed population. Alternative hypothesis is that the sample is not coming from the distributed population. And there we calculate some statistics. So you remember I mentioned that every time we are not going to plot the graph, we have other measures as well. Looking at the single value, we can say that your data is normally distributed or data is not normally distributed. And that is done by help of the Shapiro-Wills test. Getting it? So Shapiro-Wills test does not plot any graph. It gives you a number. Again, it gives you the probability value here. And if the probability value is, again, the cutoff, if you're looking at 95%, so if you look, then in that case, you need to look for the value of P less than 0.5 or greater than 0.05. And then you decide that you are rejecting null hypothesis or you fail to reject null hypothesis. So those values, those numbers comes. Getting it? So there is a test in R that is called Shapiro-Wills test. It gives you a probability. And by help of that probability, we reject or we fail to reject the null hypothesis. So no graph. Run Shapiro-Wills, you will get a value, and on that value, you can decide. I think I answered one question wherein someone was saying that do we need to plot the graph? It is not necessary every time to plot the graph. Clear? Then another is coming, Anderson-Darling test. The same one, the way Shapiro says, Anderson is also saying the same story, saying that the data which we are getting that follow a normal distribution, that is what the null hypothesis is. Alternative hypothesis is that data do not follow normal distribution. Again, he is saying that we need to look for p-value. If p-value is less than alpha, then we reject null hypothesis, else we fail to reject null hypothesis. So Anderson test also give you a value. Now the question comes that what is difference between Anderson and Shapiro-Wills? I would say that both are used in different context. So for Shapiro-Wills test, a different context is there. For Anderson test, there is a different context. That was the reason that initially I mentioned that these all tests, Shapiro, Anderson or KS, these are kind of very specific requirement. This is not applicable in each and every instance or every scenario, wherein your QQ plot is useful in almost all the scenario. And this scenario for Anderson, Shapiro or KS, we'll see later, because those are a kind of very advanced understanding that we need to develop. Getting it?
Sir, you were saying different context means what is that context? So with that one single word, we could not understand. Like normality test is something different. Context means how? Example?
Okay.
Any examples?
Okay. Listen. When we go to doctor suggest multiple tests. Okay.
Okay.
Why do doctors suggest multiple tests? Because one test
To
is
know
not,
the patient condition.
no, it's not
To
condition.
know the patient condition.
It is
Yeah.
condition is something, but the other understanding for that is one test is not sufficient enough to give you all the information.
Some diseases require different tests.
Yes, that's why we need different tests. Yes, because one test cannot give you the complete picture. Getting it? So in that case, I said that once you get your data and you are first doing the QQ plot and you are getting that your data is normally distributed. Perfect. No need to do any other test. But when you are doing the QQ plot and getting that your data is not normally distributed, but your histogram is saying normally distributed. Getting it? That means both are contradicting each other.
Sir, if we are going for a BP test, so we know that we are going to know the BP value in 80/20 is there or not. So same way, Anderson-Darling, what purpose we are going for to check the test, right? That is what I'm asking, like what purpose, which context we have to know that Anderson, we are preferring for Anderson test.
It is the second level of the test. That's what I'm saying, that you first, let's say that you went for a BP test, okay? And you are getting BP test by that pressure machine, the very traditional. Getting it? And that pressure machine is saying that your BP is normal, but you are not feeling well. Then you will realize that there may be some issue in that BP machine, or there may be some issue with me. Then you are going for this digital BP test. Getting it? Now your digital BP test is saying that no, your BP is some volatile here and there. Getting? Now you are confused that do you have BP issue or you do not have BP issue. Then how will you validate? Then you will go for a third test and then see that what the third test is saying. Getting the context?
It's a confusion. It's okay.
Now I would say that Anderson-Darling test is used in deep learning. Even your Kolmogorov-Smirnov is used in deep learning, but in the normal scenario wherein we are going to talk about linear regression, logistic regression, or some tree-based algorithm, in those cases we follow QQ test. So
Actually, sir, can you send me the few problems regarding this Sapiro test, normality test, problem with answers so that I can practice?
It will come later.
Okay. Because when we going ahead, we will not be able to recognize all those formulas, steps, everything.
At that time, we'll do the formula derivation. When Shapiro-Wills test we are going to use, we'll derive it and we'll explain that what is the mathematics behind Shapiro-Wills test, and then we'll use Shapiro-Wills test.
Okay, and each problem stated will be going to give us everything back up, like formula wise and derivative wise, everything will give and solve the problem on that stage.
Yes, so it will come to that stage. Reason being, if here we are going to provide all mathematical formula, then you won't be able to understand where the application is going to happen. So the time when application will be there, at that time we'll explain and then we'll do the application for that.
Okay.
Now, the next is coming about next is talking about the Kolmogorov-Smirnov test. Listen carefully, it is saying that it's a non-parametric test. That means a data which is not following a kind of parametric behavior, you do not know that a data is following any equation or something, then you are going to check that is it normally distributed or it is not normally distributed. So now you must have realized that the case test is different than the previous two tests. In previous two tests, we know that your data follows certain distribution. That means your data is parametric. The case test is used when your data is non-parametric. Getting it? So this is different from all three previous tests, like a QQ plot or Shapiro-Wills or Anderson. In those all three cases, your data follow certain behavior, certain predefined equations, but here it is not following that one. Look here. It is saying that less powerful for testing normality than Shapiro-Wills test and Anderson-Darling test. So are you getting what it's saying? Yes, this case test is useful, but it is not that much powerful. So in terms of the way we follow, first your QQ plot. So QQ plot is the most powerful plot to give you the normal scenario. Then the second powerful is the Shapiro-Wills. Third is Anderson, and case test is very weak test. Getting it? So that was the reason that I mentioned that the normal probability plot is something which we use widely. Now, then saying that hypothesis testing for normal distribution. So we have Z test, we have one sample t-test, two sample t-test, pair t-test, and ANOVA. And this is homogeneity of variance, that's what the Hove test, or we call it F test as well. So these are the primary tests which we use in the day-to-day life to compare that how good or bad your data is for the normally distributed data. So be careful. It is very, very specific, saying that these all tests are used when your data is normally distributed. If your data is not normally distributed, then there are other methods, other means that will talk. And this is thumb rule between Z and t-test. Just go through, you will understand it. So remember I explained that if your sample size is less than 30 and the population standard deviation is not known, so we go for t-test. The right side is talking about the z-test, and for that I explain that your sample size is here, you need to do small correction. This is greater equal to, it's not only greater than. So here this is, I would say if you write greater equal to 30, that will make better sense. That's what I explained, that if your sample size is more than 30 and your standard deviation of population is known, in that case we use z-test. I hope that is fine. Is this slide clear? And this is the formula to saying that the Z test is, this is what the formula for Z, if you remember, I explained x minus x bar or mu something, and then we divide with the standard deviation. So that is one formula. And when you are going to compare with population, so this is how we wrote standard deviation divided by the square root of n. That's what we place here at the bottom. Is that clear? This is formula for Z. Any question on this slide?
Sir, X bar is the sample of the mean, right?
Here I would say that do small correction. Wait. You can say like x minus mu divided by SC. You remember this formula. Okay.
What you said was this formula.
Yeah. That remember that formula. Reason being, the other formula which is given here, I'm just going to overwrite here. Oh wait, on this one. This is the correct one. I think the way it is given. Yeah. Remember this formula. X minus mu divided by SC. Clear?
Yes, sir. Yeah.
That is what your the better way to write the formula is. Clear? Now, then you remember for T. Yeah. Is there any question?
No.
This is for T. So if you look from the formula perspective, here also you need to do small correction that, and that correction is, wait, it is like x minus x bar divided by s, and then divided by, you can say, sqrt of n. I think that will be good enough. Wait, you remember this one, that will make the entire learning better. Got it? So I'm just going to overshadow it.
What is the x?
X is a value, a particular value which you are getting. It is your records, your observation.
Like the number of, but n is the number of samples.
Number of records. Got? And how, I will tell you. So let me perform this task, then I will tell you how it is calculated. Okay, so in both the cases, X and G, let's say that a data is given. Your data, we are calling that as X. The values are given like something, some values are given. Okay, and someone is saying that, can you calculate the Z value? Getting it? So for Z value, as you remember, the formula is written as X minus, I'm talking about take the T1. So because X bar will be easy, X minus X bar divided by, it is saying that you calculate S and then divide with the sqrt of n. Someone is saying like this. Okay, that's what the formula is given. So what is the meaning of X minus X bar? First of all, what is X bar? So let's calculate X bar here. Your X bar is going to be average of, average of this. Got it? Now then, how X bar is calculated? Now I hope you got. Then we are saying X
minus X bar.
X bar, and it is going to be equal to 14 minus 29, the mean we just calculated. That's what X minus X bar is. Got it?
It will be the summation of these values.
It will be summation, correct. It is a summation. So in the moment we write it up, summation is, in the formula usually summation is not written, it is understood. Now, then there is another more stuff. We are going to calculate T value for each and every point. Getting it? So in that case, you need to first calculate the standard deviation. What the standard deviation is coming. Getting, and corresponding to each and every number, you will be calculating T value. Like corresponding to this 14, what is T? Corresponding to this 40, what is T? So in that case, you are going to do for each and every individual. So be careful. This part is here 15. For this minus 15, for this minus 15, we are going to calculate it. Got it? Let me do here. I will do. I'm saying is equal to standard deviation. Let's say I'm calculating standard deviation of this all. I will tell you. It is saying that standard deviation is coming as 9.82. Then we are calculating this value here. and this value is saying that is equal to this much divided by this one, got it, divided by SQRT square root of, how many records are there? Can you count? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Square root of 10. Got it? Then I want to put that into the square bracket. Wait, am I doing something wrong? The name you enter is not valid. Wait, let me redo it. Probably I'm doing something. I'm saying it's equal to this one divided by, I'm saying this one, got it, and this one
Yeah,
again
divided by.
SQ.
Better don't close the bracket.
Yeah.
Okay, got it. Getting how these values are calculated? Oh, I think I need to freeze this span. If I freeze this function F4, then I can drag to here. Did you see what happened?
So for each value, whichever value we are want to check, for that particular t value, we calculate and check with the t alpha.
All right. So that's how we calculate here. I hope that is clear.
Okay.
Now, that's what this formula is saying. So if you look at the formula is saying the same story. Again, it is your call. In the way that formula was given, I was not feeling very comfortable. So I wanted to make it, I think I can't make it big because I wanted to hide all those stuff. I think it is fine. You can note down this one. Now, then coming to the two sample t-test. You remember I explained that if you have two samples, let's say that people are staying in Bangalore and people are staying in Delhi, how are their salary? Are they getting the similar salary or their salary is not same? So the way we just calculated for one sample, we calculated for one sample. Now here it is given for two samples, wherein x1 is saying that the value coming from sample 1 and x2 is saying that the value coming from sample 2. Like the information which is given for Bangalore is x1 and information which is given for Delhi is x2, and mu1 and mu2 is talking about the mean of the first sample and mean of the second sample. Standard deviation is saying that S1 is saying the standard deviation of the first sample and S2 is saying that standard deviation of the second sample. This is the same formula. The way we wrote, we just wrote x minus x bar. If you see technically, it is saying the same one, but it is saying that x1 minus x2 minus mu1 minus mu2. So your equation is expanding. It is the same equation, but considering the your two samples, this is how it is written differently. I hope it is clear to everyone. Are you able to understand this? This is not a new formula, it's the same formula, but here it is talking in terms of the two samples taken together. Perfect.
This formula, like what the mentioned formula, what is mentioned, that is applicable to all the scenarios, right? Like in independent samples, it is given as 3 scenarios.
Mm-hmm.
It is applicable to 3 scenarios, right? For equal sample sizes and equal variance.
Yes, yes. Saying that the different version of the test exists in the following scenario. Yes, equal sample size and equal variance. Unequal sample size and equal variance. Unequal sample size and unequal variance. That is the reason that here we are talking about N1 and N2. If both are N1 and N2 is the same, then it does not make big impact.
Okay.
Got it?
Got it.
Is there anyone who feel any challenge to understand what is given here? This is self-explanatory, nothing too tough. Okay. Then this is what we discuss about ANOVA. That ANOVA is something wherein we have 2 different informations are given. Like here, 3 samples are given, that is more than 2. And on top of that, we need to get some answer. That are these all 3 behaving in similar way, or this is not behaving in the similar way. Clear?
Chinmay,
Yeah, tell me.
for ANOVA, can I know the sample mean distribution give idea about the population mean distribution using ANOVA?
I would say that whenever we ANOVA is technically known as multiple t-test. So ANOVA is, I would say, the elder brother of t-test. So what all t-test does, ANOVA does exactly the same stuff. Got it?
Yeah, got it. Thanks.
So it is coming from the same family. No big difference. That's what it's saying, that the null hypothesis is mean of all the samples are equal. Alternative hypothesis is the mean of all the samples are different. Now, one case study is given for one sample t-test. Just read this case study carefully and tell me that what is your understanding. What you mean by, what are you understanding here? Can you tell me?
The null hypothesis is saying that the lifetime of a car is 10,000 kilometers. And the alternative hypothesis will be it is less than 10,000 kilometers.
It is saying that the manufacturer claims that the mean life of car is 10,000 kilometers. Getting it?
So here the x and x bar are given, and all other information is given. We can use the formula and calculate the.
Right.
Population standard deviation is not there.
It is going to be First of all, you tell me why this is t-test, why not this is z-test?
Population calculation.
Oh,
Clear? I hope it's clear for everyone.
yes, Chinmay, it is simple.
Look here. Here, null hypothesis is saying that greater than 10,000 kilometers. Alternative hypothesis is saying less than 10,000. Your x bar is given. Now, you must have realized that why x bar is written in the formula. That was not wrong, what all written in the PPT, but I didn't want you people to get confused. Here, a mean is given, sample mean, which is 9900. Standard deviation is given, getting it? And mu naught is given, that is what is the mean which we are getting, and sample size is given. We simply need to put it here in this formula. This was the same formula given in PPT. I just override to make it illustrative, but now you are getting sense what is x bar and what is mu. Clear? India, this is one example. I hope you understand it.
Yes, sir.
This is clear to everyone. So those informations are given depending on the, because if you go back to the previous slide, it is simple information is given. It is not saying t-test, z-test, whatever. Looking at the problem statement, and look here, it is saying that at 5% significance, that means at 95% confidence. So this is complete information given in this slide. If we understand it, we can answer it correctly. This is your formula, and we are putting everything into the formula.
Chinmay, but in the question he did not give at least or at most.
Yes, I will add here, but that is sufficient. Claim that the mean lifetime of car is.
He's giving exact value, so yeah.
At least. Fine.
So initially I thought that
it is two till test.
Mu naught. Yeah, I mean, since they have given the mean lifetime, I thought that mu naught is equal to 10,000. It is not. I thought that it is not greater than or not equal to 10,000.
So I modified it. Now I made it at least. It's fine.
Chinmay, one more thing, we can also do the P test over here, as you said, because it is also like all the conditions are going well.
For T test, for Z test.
Yeah, Z test. Sorry, yeah, Z test.
No, but this is saying that the sample standard deviation is given. It's not the population standard deviation. Here, the term is saying the sample standard deviation. So in that case, we cannot do the G test. It is only the T test. Clear?
Yes.
Now we put everything here and we got a value. So saying that solution, now compute the critical value of 5% significance. This is what the critical value is coming. This is coming like minus 1.69. But if you look into the T table, okay, I will showcase the T table. That's how to look there. Oh, wait.
So it's there, sir. T table.
I will. Yeah, it's there. I will open it. Okay. First of all, yeah, tell me.
Yeah. Can you tell you and do that by comparing with the alpha?
Can you be a bit loud? I didn't listen to what you said.
We have checked using T alpha less than the T confidence level. So can we check it using the P value versus alpha?
Yes, that's what we are going to do. So now your question is saying that how many records are there? 30. It is saying that you have 30 records. Got it? So now
Yes.
I am going to look at look here. It is saying that the cumulative probability, one tail test and two tail test. That's what the three numbers are given. Okay. Now I'm looking at the 29 degree of freedom. So this is what my 29 degree of freedom is. Okay. Look here. Here, this is 29. I just highlighted. Got it? Now, then we are looking at the one tail test. So this line is going to be one tail test. At what level of significance we are looking? At 95%?
5%.
95%?
95%.
So look here, the value which is coming from critical here is saying minus 1.43. Minus 1.43. Wait. Just wait. I think I need to. Wait, just a moment. For your 29, degree of freedom. Wait. One point 69. Yeah, this is the value. So look here, what is happening. So in the table, are you getting here? It is saying at 5% significance. Did you see? On the top, are you getting here 5% significance is visible? Here.
Yes, in my. Yeah. Yes.
So that is the line number 1, 2, 3, 4, 5, 6 in the sixth line. And then we are looking at 29 degree of freedom. This is 29 degree of freedom here. And the sixth line, 1, 2, 3, 4, 5, 6. Are you getting this value is 1.69?
Yeah.
Got it? Now, it is saying that your calculated value is 1.69. It is showing in the negative term because, see, in terms of your inferences, let me just find another table wherein this t value is given in negative as well. So just a moment. Give me a moment. I need to go to the bigger one. And there you will find it. Oh, wait. So this is Z. Z is here. We need to do small change in the PPT that this is not negative. Okay, this is 1.69. Got it? And this is also wait. Yeah, 1 point. This one. This is what we need to do. Got it? Now this is fine. So here also this negative sign is written by mistake. Now look here. It is saying that your table value is coming as 1.69. Getting it? from the table, wherein if you calculate these all numbers, you are going to get this one, 1.43. And this 1.43 is less than 1.69. That means this is the T critical. If anything is going this side, that is in the rejection region. And if anything is going this side, that is going in the non-rejection region. Getting it? So the value which we calculated,
The critical value will be given to us, right?
critical value, you can calculate it.
We can calculate it.
Yeah, it is. Now I will say that the moment we run the code and the query, we are not supposed to do in this way. Getting it? Will
Okay.
by help of the code will get it done.
Okay. Fine.
Is that clear?
Sir, I had one doubt.
Tell me.
Like while locating the critical value in the table, you compare the degree of freedom with the significance level, right? Now,
Significance
how
level.
to locate?
Yeah, tell me.
Now, how to locate the degree of freedom, sir?
That's what I mentioned, that you need to take it, do number of records minus 1.
Okay, okay, 30. Okay, they have given 30, right? Okay, 30
Correct.
minus 1.
And be careful. There is one more thing I would like to add here. That is particularly a behavior of your, what I say, the Z distribution. Look at this graph. Nothing is wrong in the PPT. Everything is correct, but I just wanted to make it illustrative. When you, first of all, this T table is always written in the positive numbers. Here, you will not get any negative number come. Okay? Listen it very carefully. Unlike your Z table. So in Z table, if you see, things start with negative and positive. Are you getting these are all negative numbers? So in Z,
Yeah.
you will be getting negative and positive both in terms of the table. The similar happens in T also. But the way this table is given, you have to presume if it is going to be left tail, then these all T values are negative. If you are taking the right tail, then these all T values are positive. That's how we presume, how we make the assumption. Getting it? So what all informations, when we are going to compare for left tail, this all numbers becomes the negative number. Getting it? Look here, look the symbol, what it's saying. It is saying that if it is going to be left tail, then this will become the negative T value. If it is going to right tail, then that becomes a positive T value. Getting it?
Yeah.
Now, and that was the reason that though we are checking for left tail, everything is written as negative. Getting it? So there's nothing wrong from the technical perspective. But when you look into the table, you will be getting a kind of slightly different meaning. But this is correct.
So anything like left to the 0 is considered as negative. Right?
Negative, yes. Because it's obvious. Are you getting that? Your center is 0. So anything
Yeah.
left side to 0 is negative.
So it is basically considered as a number line.
It's a, yes, that is considered as a number. Clear?
Yeah, clear.
If you take both the negative, then 1.4 will be greater than 1.5, right? The negative
Yes.
side.
Yeah. So in that case, smaller negative will be, so you are saying you are correct. So it will be minus 1.4 will be greater than minus 1.69, correct?
Yeah.
Yeah.
So
That is,
critical means like the calculated value, we call it as critical value.
the critical is what coming from the table.
That is what like we are substituting everything into formula. That value is called critical value.
Right. Now, with there, we have hardly 2
Reject
slides. Yeah, tell me.
or So since it is greater, T is greater than T alpha, do we reject the null hypothesis? Or?
Here it is saying that, look here, your minus 1.43 is greater than minus 1.69.
Yeah, so it will be it will not be in rejection region, right?
No, so look here, it should not be in the rejection region. So we fail to reject null hypothesis. Clear?
Yeah. Okay.
So when you do calculation like manually, these kind of confusion comes. Well, we have ways to write code, and in those 2-3 lines of code, we can easily do it.
Now these steps are eliminated in R, right?
This eliminated.
We are not using.
No. We have to simply write 1-2 line code, and those code does everything.
There is no like any confusion in that.
No. There is no. You are not supposed to go to the table. So there is way to get the entire numbers from the table. Those tables are inbuilt, incorporated with R functions.
Okay.
Now, then we discuss about this F statistics, that is homogeneity of variance. That what I explained about F test, and I will quickly, because we all know it. F test is used to test the significance of the variance of the two samples are similar. That's what we try to check it. That are the two samples looking similar or it's not looking similar. F statistics is ratio of the two sample variance. Look here, the test statistics follow F distribution with n-1 and m-1 degree of freedom. If you remember that how we did, we said that 15 minus 3, that was one thing, number of records minus number of groups, and then we did groups minus 1. That's what it is saying, that n-1 and m-1 degree of freedom. That is clear?
Yes, sir.
Then saying that null hypothesis is rejected if, yeah.
Chinmay?
Yeah, tell me.
Here we are not considering normal distributions, right? Or we are considering normal distributions?
These are all, F test is only done when your data is normally distributed.
Okay.
Then saying that null hypothesis is rejected if F is either too large or too small. Again, both the scenarios. It depends that how are you checking. Then saying that F test does not work on non-normal distribution. Getting here? It is only for the normal distribution.
Okay.
Other tests for testing equality of two variants are Levin's test and Bartlett's test. Those are again something which is much beyond. But yes, there are other methods as well in statistics to check for the variance. Now, this is a very good illustration of homogeneity of variance. Look in the graph, first graph, you have two distribution. See, there are two bell curve given. In first case, there are two bell curve. In right side, we have two bell curve. Are you getting what is happening in right side? Your variance is equal, where in the left side, your variance is not equal. Getting it? So this F test help us to find that if the variance in your data is equal or it's not equal. And be careful, in regression, we will be running this homogeneity of variance to test this assumption. So this is one of the assumptions in linear regression. Now you are getting the picture. It's very clear that how the homogeneity of variance is measured.
Yes.
I think this is the last slide. Yes. Then, okay. I think there are many more. Okay, let's do one thing. Let's have a break. We have some 6-7 slides. So after this, it is talking about chi-square test. So we'll talk in detail about chi-square test post break. Okay, we have some 4-5 slides to cover. So
But
it is
chi-square doesn't come under F. Doesn't come under F, right? Chi-square is comes under the normal P Z test, T test, or what that
like
kind of
that.
test, right?
Yes.
For equality of a mean, right? Means are
Chi-square,
equal
no,
in-
it is
For categorical
categorical.
variables.
That's what we discussed yesterday, like littering behavior of male and female.
Okay.
Got it?
The categorical variable are equal, right?
Yes.
If there are
Two independent category variables, we have to find the relation.
Yes.
okay.
So we'll talk about chi-square post break. So it is 12:37. Try to come by 12:50, 12 at max 12:55, not beyond that. Fine.
Fine.
Hi all. Hello guys, am I audible?
Yes, Chinmay, you're audible.
So I'm
It
not
is
sure
audible.
how many people are in.
Sir.
I think now we are good to start then. We already gave sufficient time for the people to come back. Okay. We were discussing about the chi-square. Okay. So here, some write-up about chi-square is given. I would say just go through and try to understand that what this write-up is saying. On this slide, this is quite evident, it is quite obvious that what all is written here. It is saying that test the null hypothesis that the frequency distribution, be careful here, the term. It is saying that the frequency distribution of certain events observed in the sample is consistent with a particular distribution. This is the completely theoretical or the textual definition. The way we discussed that the littering behavior, be careful. It is saying that the frequency distribution of certain event that means littering behavior is the event in a sample is consistent with particular distribution. Particular distribution, that means distribution of male and female. So the event that we are testing, that the littering behavior of male and female is similar, that's what we tested. Are you getting the same context here? Fine. Now, then saying that the event considered must be mutually exclusive and have a total probability of 1. Mutually exclusive, that means the littering behavior of female has nothing to do with the littering behavior of male. These are exclusive. That is also clear? And saying total probability 1 means if you add the probability of male and probability of female, you are getting, even you see the probability of male littering, non-littering, it is 1. Probability of female littering, non-littering is 1. I hope that is fine.
Sir, total probability in the sense all the 4 events, right?
So
Like,
understand how the process works. So the moment we are saying the probability, first of all, your total probability is going to be 100%, 1. Got it?
Yeah.
Now we are calculating the probability at male level and probability at female level. Getting it?
Yeah.
In male also, some percentage of male are not littering, some percentage of male are littering. If you add it up, it will be getting 100% for male. At the same time, you will be getting 100% for female.
Okay.
Got it? That's what the meaning is.
Got it.
It is saying that it is used. Yeah, tell me.
This chi-square test comes under the test of mean or variance?
It is not. It is neither for mean nor for variance because it is done for frequency distribution. So in frequency, there is no mean, no variance.
Okay.
Got it? Now, there is saying that goodness of fit, observed frequency distribution differ from a theoretical distribution. Again, are you getting? observed and theoretical. That is observed and expected. Then the second box is saying test of independence. Paired observation on two variables expressed in a contingency table are independent of each other. That means the way we talk about this is what we call contingency table. The way the entire process is taken care. I hope that is fine.
Sir, observed frequency is in the sense that we calculate the percentage out of male and out of female, right?
Correct.
Right.
Correct.
Okay. If it is 45% of some 100% and remaining percent of 100%.
Right. That is clear?
Clear, sir. Yeah.
So the goodness of it says it's observed that it's differing from the theoretical.
Yes.
So if it differs from the expected one, that shows that it is.
Yes. In that case, we
example.
reject that. In that case, we reject the null hypothesis. Correct. Now, then coming to this is the equation given that how the chi-square is calculated. Observed minus expected. We square it up and divide with the expected. Clear? Now go through. You will come to know what it's saying. You are getting everything. Yeah, tell you.
The degrees of freedom is in the sense we calculate the number of rows and number of columns
Yes.
minus 1, right?
Right.
That is row minus 1 multiplied by column minus.
Right. Clear? It is all three bullets, I would say. Those are what we discussed when we did the calculation. I hope that is fine.
Yes, sir.
One example is given here, wherein one data is given. Look here. Yes, no. So the first is saying that full time count 31. Yes is 31. No is 159. Count part time. It is saying that yes is 15. No is 14. Got it? Now, then here it is summing up. 31 plus 15 is coming 46, and it is calculating the expected frequency. The way we calculate it, they are also calculating expected frequency in the same way. Getting it? And here there are 2 rows and 2 columns. That's why degree of freedom is calculated as 2 minus 1 multiply 2 minus 1. It is the same process, similar calculation. Clear? Nothing new. We exactly did the same stuff.
It is 31 by 200, right? That is 40.2.
That's how it is calculating. So look here. First of all, if you look at the records, it is saying that there are total 46 out of 2 to 9. So can you calculate that 46 is what percentage of 2 to 9? That means 46 divided by, if you see, say 2 to 9, it is going to be close to 20%. Got it?
Yeah. Yeah.
Yeah. Then we are going to calculate what is 20% of 200. For this 200, we are going to calculate 20%. So 20% of 200 is coming as 40. Getting it? That's what the expected frequency is.
Okay.
So it is following the same mathematical provision the way we did.
So have a
Got it?
Yeah, it is mentioned here p-value is less than the significance level. So here, which is the p-value? So
No.
1.4.
1.47.
So, but that is not less than 0.0.
This is saying 1.47 is the chi-square value which we are calculating from this table, and for 1 degree of freedom, the chi-square value in the table is 3.84.
Yeah, that is the critical value.
That is the critical value. Yes. So 1.47 is less than 3.84. Got it?
Yeah, that first part of the sentence is fine. The chi-square value is less than the critical chi-square.
All right.
This 1.7 is less than 3.84.
Right.
And p-value is less than the significance level.
No, so here the p-value, we are looking at the 5% significance. Getting it? So in that case, we need to only compare 3.84 and 1.47. Because considering this 5% significant only, we are calculating this 3.84. So at this stage, there is no role of probability, because by help of probability only this 3.84 is calculated.
Okay, so p-value is calculated in a different way.
Here chi-square value is calculated by help of the significance label.
So I'm asking how the p-value is calculated.
It's not p-value calculated. By default, we are taking that as 95% confidence. There is no probability. So let me go back.
That is alpha.
That is alpha. Right. So if I go back to chi-square table, I will showcase. This only it will be. Okay. Or let me open the previous day slide wherein your chi-square value is there. Wait, see it. Yeah, it is there. This is the table from which we are calculating it. So this is on the, if you see here, this is what we are talking about, the significance. At what level of significance we are going to calculate. We are calculating at 5% significance, and our degree of freedom is 1. So our cutoff value is going to be 3.84. That's what given. We are not calculating any probability here. By help of those significant, we are getting the critical value. This critical value is not probability. It's a value which is coming from the probability distribution.
Okay.
This was what we just saw, that 3.84 is coming from the table and 1.47 is what we calculated. 1.47 is less than 3.84. So in that case, we fail to reject the null hypothesis. Clear?
Sir, here, like just Sharmila asked, no, p-value should be less than significant value. Means like significant level will be 5.
Tell me what is p-value here. That's what I explained 3 times. What is p-value here? What do you
P
mean?
value
by
should be like P value should be 5%, less than the 5%, right?
Fine. It is so at 5% p value, we are going to look into the table.
Yeah.
Fine.
Like what I'm asking is P value must and should, like it should be less than the significant value, right?
So the significant value which is coming from the table corresponding to this p value.
Corresponding to this value.
Yes. So for 0.05, 5% significance, that's what we just saw in the table here. So can you see here? This
Okay.
is what 0.05. This is
Is
what we
yeah,
probably say.
significant.
Right. And for
Yeah.
that, corresponding to 1 degree of freedom, we are looking this value 3.84.
Okay.
So we need to compare from this 3.84. There is no probability because by help of the probability only we got this 3.84. So we are going to compare by the help of this critical value. It is saying critical value, your 3.84 is the critical value. That is not the probability value.
Okay.
I hope that is clear.
Yeah. Clear.
Now, then coming to non-parametric, the way I explained that in non-parametric, first of all, in data science, we rarely get any non-parametric scenario. There are certain examples which we'll talk later, but one test for non-parametric is called Mann-Whitney test. It says that if your data is not normally distributed, then non-parametric Mann-Whitney test is used to compare two sample. It is also known called two sample rank test. We'll talk about this in the advanced technique, but it is good to know that there is something called Mann-Whitney test, and that is used for non-parametric. We'll discuss some of the non-parametric tests in future, and there we'll do some detailing. At this moment, for us, that is not technically required. Then the next is talking about the Wilcoxon sign test. So be careful. I will give you some idea about this Wilcoxon sign test. You will get some flavor because without any example, understanding any algorithm is a difficult scenario. This is easy to explain in Excel. That's why I'm going to explain. Let's say that there are two types of student. One is doing CBSE and other is doing state board. Okay, so we know that there are two boards happen. One is CBSE or you follow the state boards. Getting? Now, if I talk about my experience with respect to state board and CBSE, what I realize, what do people think, that getting a better score is easy in CBSE or getting high score is easy in state board? What is your thought process?
CBSE stuff.
CBSE is
Getting
tough
score. Yeah.
and state board is easy.
Because I have been in state board only. I thought CBSE stuff.
In state board we can easily get a better score, correct? I mean, in terms of the toughness, you are saying that the state board is simple. Wow, you guys are lucky enough. The place wherein I completed, state board was much more tougher than CBSE. And 70% of state board was equal to 90% of CBSE. That what was my context. Getting? But I think you people are lucky. I think in Karnataka it is. But there are many states wherein CBSE is very tough. So the state board is very tough. But no worries. We are considering this one wherein saying that CBSE is tough and state board is simple. Now, let's say that there are 10 students. I'm saying 1, 2, 3, 4, 5. They are taking some training for CBSE, and there are 10 students they are taking some training for state board from the same coaching institute. Getting it? That means their trainer is same, coaching institute is same, but depending on the syllabus, they are taught differently. Now, out of these 10 students or 10 candidates, though we know that both are different, we cannot compare CBSE with state board. Got it? Because both are having different contexts. Now, what you realize that out of these 10 candidates, these 3 candidates came in the top 10 of the CBSE. They are the toppers. Getting it? Wherein in the state board, these 2 candidates came in the top. I'm talking about top 10. In both the conditions, I'm going to consider top 10. Fine. And then we compare that is the teaching methodology is equally effective for CBSE or it is not effective. In both the cases, the teaching methodology is equally effective to CBSE as well as for the state board. Getting it? So here, we do not look at the percentage. I am least bothered that what percentage these 3 people got and what percentage these 2 people got, because I know that CBSE is tough and state board is easy. So maybe a guy who is getting 90% in state board will be tough for that person to get even 80% in the CBSE. Getting it? So we cannot compare on the score. Did you get it? Is this example clear what I demonstrated?
Yes, sir. Yes.
Now, then in that case, wherein we need to compare that is the teaching methodology is same for my null hypothesis is going to be that teaching methodology is equally effective for CBSE as well as state board. That means there is no difference in the outcome for CBSE as well as state board. This is null hypothesis. Alternative hypothesis is saying that no, there is difference in CBSE and state board teaching methodology. And there I am looking at the rank that those who were in top 10 in the coaching list, how many are, so out of those top 10, which rankers are coming in the top 10 in Karnataka, and those who are in the top 10 coming from the state board, which all are coming in the top 10 of the state board, and then we are comparing it. This is what your slide is saying. So if I go back to the slide, this is what the Wilcoxon sign test is. So sign test is, it's saying that the Wilcoxon, are you getting that rank test is given here? Sign rank test. Is it clear? So we check for the rank that in the given number of records, how many records are getting high ranks and what is their position. So it is saying that Wilcoxon sign test is a non-parametric statistical procedure for comparing 2 samples that are compared, like sample with CBSE and sample with the state board. Am I audible, guys? Can you hear me?
Yes.
Okay. Perfect. So it's saying that the parametric equivalent to Wilcoxon sign and test is by name is such as the t-test. So if you, so remember the t-test. In t-test, we used to compare if the same information is given, if the same thing we are going to do considering their marks, that what percentage of marks they got, it will become t-test. But as I mentioned that we are not going to consider their marks, we are going to consider their rank. That in top 10, where are they ranking? So if we are considering their rank, it becomes the Wilcoxon test. Is it clear? Are you getting that flavor?
Sir, what is the meaning of that matched pair, sir? Like t-test for matched pairs.
T-test for matched pair. So again, it is matched pair. If you remember the placebo impact, when I say that
Yeah,
the
okay.
same, that the matched mean for the same people we are doing it.
Okay.
Clear? So it is something which is non-parametric, and this is slightly tedious. So these tedious activities we'll do in the later phase of data science learning, not at the initial phase. It will create a lot of confusions. So in learning, what is the ideal way? That first we need to learn the widely used techniques which help us to answer majority of the questions, and then we figure out that what are the limitations of those techniques, and then we learn the other techniques which answer those limitations. That's how the ideal process is. We should not learn everything in one go, because that will create complete hodgepodge scenario. We'll follow the same methodology wherein the techniques which answers majority of the questions we are going to do first. Later on we'll discuss that what is limitation of those techniques, and then we'll talk about the other techniques which answer those limitations. Clear? I hope this Wilcoxon, you are getting the sense from this Wilcoxon sign test. If not, you need to wait. When we, in the advanced technique, when we do something non-parametric, we'll cover over there.
Chinmay,
Yeah, tell me.
since we came to the end of this slide, these presentations, so I have a question. So we have two distribution, normal and not normal. So for normal, we have the p test, z test, and all. For non-normal, we do have that the means of the random samples follow normal distribution. In case, maybe that is how they test in the data science. I'm not sure. So
Right.
what do you do with the non-normal distributions?
Yes. So
suppose,
yeah. Complete.
Suppose a data which has given to any of us is not a normal distribution.
Mm-hmm.
Do we take the random sample means and then draw a normal distribution and then assign something to it, statistical analysis?
No. There are processes which we'll be learning. That if your data is not normally distributed, then how to make it normal. So we make it normal. And for that, there are certain ways to do it. I'm just giving one example that may give you some idea. Let's say that your data points are given like 10, 100, 1,000, 10,000, likewise. And if you see, it does not seem like normal. Let's say that another is wherein we have 5 zeros. It is not looking like normal. Got it? This is my x.
Yeah.
Then what I'm doing here, I'm saying I'm going to do log of x. And look what is happening. The moment I say log of x, did you see what happened?
Yeah, it became a log normal, not log normal.
It is something which looks like in a very good shape. Getting it?
Right, but still it is not normal.
Tell me.
It follows that y is equal to mx plus c equation. If you plot this particular graph.
No, that is something which we'll talk in the regression. But here, what I wanted to explain, that your data x is given, which is not normal. The moment I did some log transformation, I brought that back to a very good label. It is still not very normal distributed, but you can see it is good enough. Getting it?
Yeah, but the true essence will be lost, right? If you're applying some
But
long
again,
function.
again, as a data scientist, our role is to ensure back that we are not losing majority of the stuff. Yes, we lose something, but again, if your data is something is not given in very good context, then certainly we are going to lose something. Got it? But what is remedy? How to take it up? That's what we'll talk.
Yeah. So how not to lose the essence? We have to give some additional, disclaimers or something for the district.
There are some things that we do, I would say. Fine.
Cool. Thanks.
Sir, in this particular case, like you done the transformation, right? So once the transformation is done, you will be applying that Wilcoxon test and other tests that are not non-parametric tests to this particular distribution, right?
So here, first of all, I will try to make it normal. Okay, and be careful in the statistics. Your majority of the algorithms, majority, I'm saying more than 95%. More than 95% algorithm has understanding that your data is normally distributed.
Okay.
That is understanding. So we need to put every effort to make it normally distributed, because there are hardly handful of techniques which answer your non-normal distribution.
Okay.
So if your data is not normal, then there are ways to make it normal. Still, if you're not able to make it normal, then we need to find other ways that how can we do it. But that is not a very good scenario. We assume that the moment we are going to take data from a huge population, and your population, any population is supposed to have the normal distribution. It is. Take any example. Like if you talk about the blood pressure of the people, if you take the sample of 10,000 people blood pressure, you will be getting that it follow normal distribution. Like some people will have, majority of the people will fall at the average level. Some people will have very high blood pressure and some people will have very low blood pressure. That means your majority is, your peak is happening at the center. And center is the normal, the average.
Yeah.
Getting it?
Yeah.
Same time, if you take the height of the Indian population, you will be getting that there are very small percentage of people whose heights are very less, let's say less than 4.5 feet. I'm talking about a person who is at the adult level. Fine. At the same time, there will be very less percentage of the people, their height is more than 7 feet or 7.5 feet. But you will be getting that majority concentration is happening between 5 to 6 feet. Getting that?
Getting it.
So that will also follow normal distribution. So it is presumed that the data which you are going to get from the population, it bound to follow normal distribution.
Yeah, my question is that, sir, if our data distribution doesn't follow a normal distribution, so we make some adjustments so that it follows normal distribution, right?
Right.
Now, once this now the data that is normalized, which technique is used? Do we use the technique that are used in normal techniques, or
yes, in the normal.
the techniques which are
normal,
right?
Yes, because we normalize the data.
Okay.
So now we can use normal techniques.
Okay.
I think it is clear.
Yeah, clear.
Now we are going to do an exercise wherein we'll be answering some of these questions. Okay. And for that, this will be interesting, I would say. And
Chinmay, your voice is not audible.
no, I'm not saying anything. I'm just opening this one. In last 15-20 seconds, I didn't say anything. Now, am I audible now?
A little bit.
What about others? Because I find that I have proper connectivity.
Audible.
Because whenever, you must have realized that whenever I find that a message comes saying that you may be facing challenge in your audio and all. So those messages will be visible to you as well when that comes. Now we are going to do some process, okay, and I will tell you for that we have one problem statement. It is saying that how to do data manipulations and preparation in R. It's one assignment kind of stuff is there. I'm going to complete, and you can follow this one. So this one is having two sets of the data. One is this sample data is having about one data is having for house feature, and second is talking about the house sales data. That is the sales related values are there. So we have two sets of the data that we are going to use, and considering that data, we need to follow certain tasks. So first, let me show you the data. Okay, now the data is. The first is the house sales data, and second is the house feature data. So I'm going to read it. This is house sales data, wherein I have ID, house type, distance from the street, carpet area, house condition, built year, renovation year, number of bathrooms, fireplace, garage size, garage area, year sold, sales type, how it is coming direct agent, contract direct, and the sales price. So this is the house related information given to me. It's a sales related information. Then other is talking about the house feature, and this is how the house feature is. So this house feature is having two variables: ID of the house, zone, in which zone it is coming, utilities, what kind of like gas, electricity, etc., and landmark. That is there any landmark like university is near, hospital is near, some school is near, likewise. So these are some features given for your house data. Got it? So we have two sets of the data that is given to us. Now, let me close all previous slides because it is unnecessary creating some issues. Now, your first problem is saying that it's saying that set your working directory and check your working directory. So it so happened that when you work in R, it is important to know that where your working directory is. Fine. And there is a command which we write, and that command is getwd, get working directory. The moment I hit it, it is giving me the path where my current file, everything is being stored. So this is what the get working directory, getwd. It helps us to find that where my working directory, the folder where I am performing all the tasks. Can you run this code? I'm going to ping it. You can simply run in your terminal. You will be getting some location is coming. Can you run this code? I pinged it. Did you run this code?
Yes, sir, ma'am.
I hope it is working for everyone. Are you getting some output?
Yes.
Perfect. Now, then let's say that currently my working directory is showing somewhere like C drive user here and there. Okay. I want to change it. I want to change my working directory. That means I want to store the entire stuff somewhere else. So let's say that in my case, I have a folder on desktop and that folder name is scrap folder. I want to change my working directory to this scrap folder here at this place. Okay. So I need to copy path of this place. So look here, the moment I'm going to the address title here, I copied it, and in order to change this path, I need to write set wd working directory, and I am passing the new path where I want to set it. Now be careful, R does not understand this default slash because this is symbol for division as well. So you need to do double slashing. So be careful whenever you pass the path extension, you need to change this, you need to alter this. That means now I am going to change my working directory to some other place. Now, I have not yet executed line number 11. I am running line number 13 to showcase where my previous working directory is. So previous working directory is saying that ed_ematicus, that is one of the file. Now I want to change to the new place. Okay. If I am changing to the new place, I executed line number 11. It has changed, and then I'm going to run. Then I'm going to run my working directory. So look what message is saying. It is saying that now my working directory is on desktop. There is a scrap folder. It is no more into the ematicus folder, which was earlier. Did you get what I did here? I hope it is clear to everyone.
Sir, old previous files also it is got transferred to this your new file, right?
No, the new one. So what all you are going to do,
henceforth everything will be stored.
Right.
Okay.
I hope it is clear.
Yes, sir, clear.
Anyone who has any concern or any challenge in this part? It is perfect. Now, then your slide, that's what was slide saying, that set your working directory and check your working directory. So we set our working directory, after that we check our working directory. Then next is saying that we have two data. One is the house sales data, another is the house feature data. We need to merge it, merge the multiple data sets. So we have two data sets with common column. In both the data set, if you see, the ID is column. Getting it? So by help of this ID, we are going to merge both the data sets. Got it? Now, for that, what are we going to do? We are using a function called merge and saying house sales data and house feature data, and using this by function and saying ID. I want to merge it by ID. Got it? And if I run it, look here, my house data is created. I created a new data called house data. And if I open it, look here, what is happening. In the house feature data, I had 4 variables. In house sales data, I had 14 variables. Got it? And the new data which is created, which is having 17 variables. Why it is 17? Why not 18?
One is
In
common,
that
right?
reference,
Common. Perfect.
One is common, that is eliminated.
Right. So ID is common. So now, if I open this house data, wait, you will be getting that this data is having those informations been added here, like zone, utilities, and landmark. Did you see that information is added?
Yes.
This is how we merge the data depending on the common attribute, that is the common variable. So this is what this problem statement was saying. Okay. Then we are going to do some data exploration and visualization, like we are going to see the summary of the data for numeric, character, standard deviation, correlations. We are going to do a lot of stuff. So now I am moving back to the coding part and I will explain you. Now this data which I have, the house data is my final data which I merge. And this house data is having some numeric variable and some non-numeric variable. Clear? Yes or no?
yes, sir.
Yes.
Now, when I run the str, that is structure, you remember what happened in the structure? It gave me information about the variable types. So if I run it, look here. It is giving me information. It is saying that ID is integer, house type is integer, distance from the forest is integer, carpet area is factor. So carpet area, it is taking factor. Let's look into the data, that why carpet area it is taking as a factor. Got it? And for that, I will go back to the data wherein the house sales data is given. So let me do a copy of this data and come back to the scrap, because I do not want to disturb my original data. Wait. Now look at the carpet area. What is happening in the carpet area here? That these are given like numbers, some missing values are also here. I'm getting it? And that may be one of the reason that it is considering carpet area as a non-numeric. Getting? Wherein the distance from the forest is also having number and ns, but if you look at the data, distance from the forest, it is taking that as integer. Getting it? So that is one challenge for us. The moment we read the data, though our try to do the interpretation or reading in the best possible way, but there is no guarantee that it is doing everything correctly. That's what we just saw. Clear? Did you get what I said?
Could you please repeat it, sir?
I said that what I demonstrated in Excel here, that there is one variable called distance from forest, and there is another variable called carpet area. Getting it? Carpet area is having some numbers as well as some missing values. So this NA is indicator of missing values. Got it? Distance from street is also number, but it is having some missing values. Got it? I load the data.
Okay.
In terms of look and feel, both columns are looking similar. But the moment I run the summary, I am getting distance from the street being considered as integer, wherein the carpet area is considered as factor. Getting it? That means R is trying to interpret its own way, but this is not reading it correctly.
Because distance from street also has the missing values, right?
Yeah, both has.
So
Distance from street and carpet area both have the missing values.
So in that case, the district from street should also be considered as factor.
No, so I'm saying that both variables are having similar behavior, but both are
Okay.
differently. Correct?
Okay. Correct.
So here the user intervention is required. So we need to make that either all as numeric or all as the character. We'll talk later. But I wanted to sensitize here that whenever we read the data, it is very important for us to run this str structure to know that how the reading of data is happening by R. Clear? Clear?
Clear.
Now, then we are going to run next called summary. So when I run the summary, I will be getting some informations. Look here. It is saying that house type, it's a number. So you are getting all statistics. Distance from street, all statistics. It is saying that there are 46 missing values in the distance from the street. Getting? In carpet area, look here. It is not giving you statistics. It's saying that the 15 yard has come 16 times. 65 yard comes 16 times. 225 yards come 15 times. So this is giving you the frequency. Getting it? And it is also saying that you have close to 24 missing values. Fine? Likewise, we are getting many more summary. Sales type, contract agent, 365 houses. Contract direct, 387. New agent, 357. New direct, 340. So these are the different ways people sell their houses. Clear? Is that fine?
Fine, Chinmay.
Now, then we are going to look the class for carpet area. So if I run the class here, it is saying that class for that is factor. That's what we just saw. Getting it? Now, what we need to do, first of all, in your data, I wanted to explain you that why it is happening with carpet area. Okay. So let me go here. And you see, how these NAs are written. I think. Are you getting sometime NA is written as small n a and sometime that is written as upper n and a? Getting it? In your data,
Yes,
did
sir.
you realize?
Yes.
That is the reason
Yeah.
I'm
Yes, yes.
understanding that as a character. It is not getting that missing value is written properly. So it is considering that as a character. Got it?
Like it will take capital letter only, right, sir? In A.
So first of all, suggested to just put that as a blank. If you leave that as a blank, it will automatically read that as NA. I will tell you what is happening. If you open the data here, carpet area, it is saying NA. Let's look at the small NA. Where all those small NAs are coming. It is very rare instance. We need to find where is it. Let me know if you
Sort it out. Sort it out by
Yeah,
Karpate.
I will. That will be useful. Are you getting these are the values? So look here, how the missing value is read. So if you get missing value like Na, it looks into the light Na color. Wherein if you are passing something like this Na, it is considering that as a value. It is not considering that as a missing value. Getting it? Look at the background color. I hope that is clear. Are you getting what I'm saying?
Yes, Chinmay.
If there is a missing value, then R consider that as Na, but this Na is written in the light color. But if you are writing manually by Na, it is not considering that as a missing value. That is considering that as an information. Fine. Let's go up. See how the upper Na is looking like. See here. These are the other NAs. Getting it? So this Na is written in two different ways into the data, which is confusing R. So what we need to do for that? First of all, we are going to do some treatment. And be careful. We know that it's a number. Carpet area is number. It's not a character. And not a factor. So first of all, we are going to convert a factor into a number. So be careful. In R, I wanted to write something. If you want to convert a factor to a number, you cannot do it directly. You need to convert factor into character, and then you can convert character into number. That's how the process happens. You cannot do directly from factor to number. Getting it?
Okay.
Now, this is limitation. And I would say it's not limitation, that is a good behavior. So what I'm doing here, the moment I run the class of the carpet area, I got that as a factor. I am converting that as a character. So I'm saying that as dot character, and on this housing carpet area, I want to convert it. So once I convert it, and then I'm running the class of the carpet area, you see now it is saying character. That means your data carpet area is converted from factor to character. That is clear?
Yes.
Now, your voice is not audible. Is someone saying something?
Yeah, we need to execute the 44th line first, and then we need to execute the 42nd, so that the carpet area will be characterized.
I would say this
The
is
carpet area,
this is just for checking. So I would say that you first executed 42 line, then executed 44 line, then you are going to execute 45 line. 45 line is same as 42 line, just for checking.
Okay.
Got it?
Got it.
Now, then I am writing a condition saying that if else, the carpet area is, be careful, it's double equal to. So I'm saying that if carpet area is Na, or if you're saying that carpet area is Na, if written like that way, then convert that into Na. So if it is written in lower Na, you want to convert that into Na. So what would you do where all this is Na is written in small letter? You are going to convert everything like Na, and this Na is missing value. So you are saying that this small Na is going to be a missing value. Is that clear? Did you get what is happening in line number 47? I wanted to convert. Yeah.
If the values are mentioned as small na, those are converted to capital Na, right?
Those are converted into capital Na, and capital Na is indicator of missing value. That's why you see what is the color of NA coming automatically. It is coming in the blue color.
Actually, line number 44, we are not changing anything like a small lowercase NA to uppercase.
No,
We are directly changing the character type, right?
correct.
We are changing the character type. In the 47, we are changing the small letter to capital letter.
All right. Is that clear? I hope that is fine.
So this capital NA, what it is that is indicated in the blue color, that is indicated in purple color. That is the the value that we provide, or is it the value that is missing? I mean,
this is
the
given
color. There was some variations in the coloring, right?
Yes. So this NA, which is coming in blue, this light green color, that is how it is coming from your data. It is data, and this NA, upper N and A, this is how you want to convert it.
So it will be in solid color, right? In the data set.
Yes, it will be done in the data set itself. Got it?
Got it.
I did it. Once it is done, then I want to convert this carpet area as a numeric. I mentioned that from factor we convert into character, and from character we are going to convert into numeric.
Yeah, correct.
Getting it? So now in line number 50, we are converting that into numeric. We did it. Okay, it's a warning message, no worries. Okay, then look at the run the class. So if you run the class, did you see now how it is coming? It is saying numeric. Your carpet area is now converted into numeric. Did you get it?
Yes.
Now, once that is converted into numeric, what are we supposed to do? If you run the summary, I will come to know. Here I am running summary only on that particular variable. If you run summary on the house data, it will be giving output for all the variables. Here I am saying in the house data, I am looking for carpet area only. So it is saying that minimum is 55, maximum is 350, and some NAs are there, some missing values are there. Fine, we are okay. There are some missing values, we know it. But now it is numeric, it is no more character. Clear? I hope that is fine.
Yes.
Now, I will share this case study. This is one of the case study, and a high level of code is written, and you will be getting a lot of distributions, everything which we are going to do to understand normality. Everything will come. So what all we discuss, majority of the stuff you will be getting here in this exercise. Okay, I will share this code along with data. Do some practice and then come to the next class. I think that will be helpful to understand the concept going forward. Fine?
Sure, Chinmay. Yeah.
And the second is we are in the process to increase the time from 3 hours to 4 hours. And I hope there would be some discussion with Martigas. Did anyone approach you for 3 to 4 hours?
No, Chinmay.
Okay, I need to remind to Sadaf. So one discussion.
No, sir.
Okay, one discussion. Because ideally it should be after a month time. It should be 4 hours. Reason being 3 hours is not sufficient to have the proper kind of the complete momentum. That is one thing. Second is the recorded file. I will be deleting those recorded files which are more than 15 days old. So you need to ensure that you have everything in place. Do not Once it is deleted, do not message me saying that no, I have not I have not downloaded it. So please do it. I will not do it today, but essentially tomorrow or day after tomorrow, I will do it. Clear?
Yeah, clear, Chinmay. Chinmay, then you share this house data set, house
I
data
will
file.
share. I will share the code, data, everything. I will share.
Yeah, sure. Thank you.
Fine. So we are going to close here for today. We'll see you next week.
Yeah, Chinmay.
Thank you. Okay. Bye.
Thank you. Bye.